two Hot Wheel cars are in a straight line on a frictionless surface. The red Hot Wheel car weighs 7 kilograms and the blue Hot Wheel car weighs 10 kilograms. If baby Kevin pushes the red Hot Wheel with an applied force of 2 newtons while the cars were started at rest, how far will the cars go in 5 seconds and how much force is applied from the red Hot Wheel onto the blue Hot Wheel? So, to start it off, you need a lot of basic information. So, over here, we have the different force diagrams you need. Red representing the red Hot Wheel, blue representing the blue Hot Wheel, and green representing the both of them together. So, the first thing we need to start with is the red diagram. What we know from the red diagram is we can find the gravitational force. So, the gravitational force is equal to the force of gravity, which is 9.8 meters per second, and we multiply that by 7 kilograms.
It's meters per second.
You're right. It's meters per second.
Can't forget the squared.
Never forget the squared. Then, when you multiply those out, you will get 68.6 kilogram meters per second squared. This then goes to 68.6 newtons. Gravitational force and the normal force both cancel each other out. So when we found the gravitational force, it's also the normal force. Now, from this problem, it says that baby Kevin has an applied force of 2 newtons onto the red car. So, over here, you can put that the force applied is 2 newtons. Okay, now we completed that, so we can move on to the next one. So, with the blue car, this time, for the gravitational force, we're going to use the same process, except this time it's going to be 9.8 meters per second squared times 10 kilograms. That gives us 98 kilogram meters per second squared, which goes to 98 newtons. So that goes here, down at the bottom with the arrow going down, and at the top where the normal force is. And for this one over here, the applied force is whatever is put from the red. So for right now, you could put the force of the red car. Okay.
There's also the force on the blue car pushing back because they're touching each other. So since it's asking for the acceleration, now Alyssa has to add together the masses of both the cars and make it into one force diagram so she can find all the forces and then eventually use the sum of the forces equation to find the acceleration.
So to do that, all we did was combine the 7 kilograms and the 10 kilograms to make a 17 kilogram box. So we're going to keep doing the same process with the gravitational force. So it's going to be, this time, 9.8 meters per second squared times 17 kilograms. Then that leaves you with 166.6 kilogram meters per second squared, which we all know now equals 166.6 newtons. So that goes right here once again and up on the top. And the force applied for this stays the same because when you combine them together, it's all 2 newtons. Now that we have all of our basic information, Gina can help us now find the rest of the question.
Thank you, Melissa. Okay, so now that we have all this basic information that Alyssa found out for us, we can try to solve for the acceleration now. So, for the red car, the sum of the forces is equal to mass times acceleration. That's Newton's second law. So we know in this equation that the mass is 7 kilograms, but we don't know the acceleration yet, and that's what we're trying to find in this problem. So now we have to find the sum of the forces in order to solve. The sum of the forces for this would be equal to the gravitational force minus the natural force plus the applied force minus the force of the blue. So the gravitational force and the natural force cancel out because they're the same number, but they're one's negative. So that leaves us with the force applied minus the force on blue is equal to 7 kilograms times this. But we don't have, well, we do have the force applied because that's 2 newtons. But we don't have the force of blue pushing back on red, and we can't have two variables in the same equation because then we can't solve it. So we have to continue finding the sum of the forces for each one until we are able to find the acceleration value. So to do it again on this one, the sum of the forces is equal to mass times acceleration. The mass is 10 kilograms this time, and the acceleration we still don't know. So in this case, it's the natural force minus the gravitational force would still cancel out because they're the same value. So that leaves us with adding the force of the red car on the blue, which we don't know. So we still are unable to find the acceleration because we still have a missing variable. So if we go to the third force diagram of both the masses added together, again, we know that the natural force and the gravitational force cancel out. So that leaves us with the force applied equals mass times acceleration. So we know the force applied is 2 newtons. The mass is 17 kilograms. And that leaves us with only one variable of acceleration. So if you divide 17 by 2, you get acceleration to be 0.11765. So that answers the first part of the question, and you should always remember your units, which is meters per second squared. So now that, whoa, we didn't answer the question yet. Now that we have the acceleration, we can go back into these previous sum of the forces and find the force of the red on the blue. Because then that will leave us with only one variable. So if you go back to the blue car, the force of the red is equal to 10 kilograms times 0.11765 meters per second squared. So if you multiply that out and put it in the calculator, then you get that the force of the red car on the blue is equal to 1.1765 newtons. This is the red Hot Wheel onto the blue, but you should notice that the red and the blue have the same amount of force pushing back on each other because they're touching. So 2 newtons minus the force of blue equals 7 kilograms times the acceleration, which is 0.11765 meters per second squared. if you multiply this out and subtract this 2 over here, so if you subtract it from over here, that leaves us with the force of the blue is equal to negative 1.1765. So then, like, obviously you can't have a negative value of force. So if you just divide this by negative 1 and this by negative 1, you get the force of the blue on the red to be the exact same number as here. That solves the first half of the problem, but now we need to find how far the car will go in 5 seconds, which Alyssa will show you how to do right now.
Okay, so when we have to find how far it goes, we have to go back to our old displacement equation. So our displacement equation is displacement equals the initial velocity times time plus 1/2 times the acceleration times time squared. So when we do this, because we have an initial velocity of 0, this part cancels out. So we're left with displacement equals 1/2 times acceleration times time squared. So then it's simply just plugging in numbers for it. So we know our acceleration of 0.11765 meters per second squared. So we can do 0.5, since 0.5 is the same as 1/2, times 0.11765. And then we can multiply that by 5 seconds squared, which is what the problem is asking us. Then we get 0.5 times 0.11765 times 25, because 5 squared is 25. Then we end up with an answer of 1.4705 meters. So, to answer our question, the cars will go 1.4705 meters in 5 seconds, and a force of 1.1765 newtons is applied between both the red and the blue car.